Right, so hello everybody, welcome to the CollabNet and XebiaLabs webinar today. We've got a very good, interesting topic today. We're going to be talking about how we can take the CollabNet platform and build out a true DevOps solution, including your planning, your code, your build, and actually the deployment step out into your infrastructure. So that's what we're going to be talking about today. So start with a bit of an introduction of who I am. So my name's James Mounterfield. I'm the pre-sales director for CollabNet in EMEA. I've actually been with CollabNet for nearly 7 years now, and I've worked in this industry for over 10 years. So I have a lot of experience with this sort of realm coming from the development side of things. I've had a lot of involvement with change management systems, version control systems, and a lot of emphasis on sort of the free and open source components that have been increasing in availability over the last decade. So that's a bit about me. I'm going to be talking through the contents of this webinar today. We also have our team that are helping to run the webinar. So if you guys have any questions during the course of this session, please do interact on the chat. We will do our best to answer your questions as they come in. If we get too many questions or we don't get any of them answered in real time, we will be following up with answers to those questions. So do please feel free to put questions into the chat. So the first thing we need to cover is who is CollabNet? Why do we feel we're qualified to talk to you about these topics? So CollabNet was actually founded a little over 15 years ago now. And CollabNet was originally founded with the vision of enabling enterprises to take advantage of sort of the emerging best practices and technologies that the open source projects were using at the time. You know, we had things like the Apache Software Foundation, building the Apache web server. And these were groups of people using very, very lightweight tooling, spread out geographically distributed and with a minimal set of infrastructure supporting them. And CollabNet wanted to take those technologies, bring them together and package them up in a way that could be consumed by the enterprise. And that's where CollabNet got the idea for building a platform for software development. You know, since the day it was founded, CollabNet's really been leading the adoption of these technologies. More recently, CollabNet's been driving the adoption of Agile development, and from the very beginning, CollabNet's been offering, you know, your software development environment as a service. Long before cloud was called cloud, it's been software as a service since the very beginning. CollabNet also has an awful lot of experience in many different vertical industries. I mean, we've dealt with financial, healthcare, global services, all of those different verticals. So we have a lot of experience of taking our platform and our technologies and making it relevant to what our customers are doing, and we've proven that over the last 15 years. Some of the details on this slide help call that out. So how does CollabNet actually do that? Well, the CollabNet technologies are based around one main product, which is the CollabNet TeamForge platform. This platform is designed to offer the set of tools and processes that your software development teams would need. And more recently, we've been extending that platform to incorporate more of the software development lifecycle. So this is the CollabNet blueprint for enterprise agility. This is part of our vision. This is the value that we think that organizations can get out of adopting the CollabNet technologies. And you can look at this as sort of a maturity matrix of where we would like our customers to move to. And this is based on what our customers have been doing over the last few years. So I want to spend a couple of minutes talking about this blueprint for enterprise agility. And that should put a lot of what we're going to go on and talk about today into context, why we're discussing it. So these first three steps, the idea of embracing the cloud, implementing community architecture, and codifying dev processes, these are really the state of software development today. These are things that every organization that has software as a critical part of their business should be doing already. So let's start at the very beginning, the idea of embracing the cloud. Now, this can be quite an emotional topic, especially using the word cloud. What we're really getting at here is the idea of starting to think of your software development toolchain and processes as a service that are consumed by your development teams and the other stakeholders, rather than a selection of point tools. So instead of having dedicated point tools installed locally in specific regions, we would want to start thinking about these more as a generally accessible service. So the idea of bringing together, say, your version control services into a central location that your users consume like a service. That is the idea behind embracing the cloud. Now, you can do that internally, so your own internal services to your users, or you can go externally. You can come to someone like CollabNet. We can provide our TeamForge platform as a hosted service that is available to your entire organization. You can build your own services. So the next step is implementing a community architecture. This is really building on that centralization and starting to look at your processes that you use and encouraging things like reuse. Traditionally, when we talk about reuse, everyone immediately thinks of reuse of assets, code reuse, reuse of IP blocks. One of the best opportunities for reuse is actually the reuse of process. So this is something else that we want to enable with a platform like TeamForge. The idea that your best practices and your most mature teams, their way of working can be reused across your organization is key here. The ability to collaborate and do all the other things around just building the software. So you have things like your discussion forums, your channels for communication between your teams, and actually communicating with your customers, where products and services that are built within an organization are reused within that organization. These are your customers. You want to bring these people into your environment. And then that third step is the codifying of dev processes. So this is really about automation of your development chain. Almost every organization these days is doing continuous integration, or at least some sort of continuous build, but also codifying the way you work with, say, your change management data. So supporting Agile, waterfall, mixed processes across your teams, but actually baking that process into your tool chain, making it easy for the teams to do the right thing, and reducing the overhead of all of the sort of the standard steps that your users would go through when they do their development type activities. Every bit of effort that is invested in automating or codifying these sorts of processes is usually very well invested effort. This pays off. These processes get reused over and over again. So these three steps really make up the state of the art today of what any organization that develops software or has software as a critical part of their business should be doing. And the next two steps are where we can start really ramping up the value of this sort of infrastructure. So the fourth step that we have here is Orchestrate Devops. And this is the idea of crossing the boundary between your development organizations and your operations team. So automating that delivery process from dev to ops. And it's also about extending the responsibilities of the development teams into that operations world. And your operations guys starting to think of their role more in a capacity management role, a development infrastructure services that service the dev teams that actually deploy the products and applications that make your business successful, that add value to your business. So it's a very, very broad chain DevOps, and this is where the CbiaLabs topic really starts to kick in. So CollabNet TeamForge provides really good a really good platform for these first 3 steps, and it provides a really good foundation for extending out into step 4 and in fact step 5 that we have on this diagram today. So step 5 is really about extending that DevOps vision to external clouds. This is where you start looking at leveraging things like Amazon Web Services or other commercial cloud solutions for really taking advantage of the economies of scale that exist outside your organization. These could also be internal clouds. Depending on the size of your organization, you may be able to achieve those economies of scale internally as well as going to external services. But the CollabNet platform, is a really good basis for both of these topics in the top right-hand corner here. One of the things that CollabNet has always done is we've looked for partners for enabling us or enabling technology to reach these steps. There's a couple of reasons that we've relied on partners to do that. Let me just go to the next slide. So this is part of the view of where the CollabNet products sit, where they service different parts of the software development lifecycle, everything from planning all the way through to the deployment and operation of your products or your applications or whatever that may be. And one of the reasons we've relied on partners and integrations to actually achieve the deploy and operate part of this picture is because we have such a diverse selection of customers. What the deployment and operation actually looks like for our different customers and the different industries we work in varies so much. It's almost impossible for us to consider building sort of a centralized tool for this. So, for example, if you're working in embedded systems or sort of mixed hardware-software environment, the idea of deploying and operating software or embedded designs or IC designs, that sort of thing, the actual deployment step is usually a quality gate or a deployment to a PLM system or a deployment to manufacturing. For our other customers, this deployment step might actually be the publishing or the pushing of your software into the hands of your customers as an app that they run themselves. Or you might be running your own production operations center. So you're actually deploying your own apps and services internally, either for your external customers or your internal customers. And this is a really diverse selection of deployment scenarios. So CollabNet is focused on partnerships to achieve this deployment piece. And one of the partnerships is with the CebiaLabs products. So this is what we're going to be talking about today. And I'm really going to be focusing on how we move through this life cycle from planning to code, actually making changes to the source code of our products, how we build those changes into some sort of deliverable. We're going to move through the testing phase very quickly, and then we're going to be really, really focusing on the release and deployment of these assets into our operational environment. So this is a more sort of focused view on actually what I'm going to be showing you today. So this is the sort of more practical standard layout of example toolchain that we would see. So the CollabNet TeamForge platform is on the left-hand side of this picture. It offers some standard services as part of the platform. So we have the tracker as the change management component. We have the collaboration tools like discussion forums, wiki, documentation, reports, that sort of thing. And then we provide the sort of the harder tools that your development teams are actually going to be using to build the product. So we have version control services, things like Subversion or Git. We've got code review and code search. So code review is provided by Gerrit or Review Board. We've got Black Duck Code Site integrated for code search. For actual automation and build systems, we're going to be using Hudson or Jenkins. And then we've got integrations out to third-party tools where necessary. So part of the idea here is that TeamForge can provide the backbone of everything that your software development team does, from planning your application or product all the way through to the release of that product. And we would, as I said, look for partner integrations for dedicated point tools where they're required, and also to achieve the DevOps push to operations point or view of this. This is part of the sort of the deployment step. So the XebiaLabs products really fit in very nicely across this DevOps boundary. The integration is very strong and the value proposition is very compelling. So as you can see, the main three XebiaLabs products we're looking at is XL Release, XL Test, and XL Deploy. And these things all come together to help you manage that DevOps boundary, the classic divide between development and operations. Today specifically, we're going to be looking at the XL Deploy product. We're going to be seeing that in action as part of a TeamForge project. And I'm going to show you how we can go very, very quickly from a defect report all the way through to deploying the updated version of our application into our development and into our production environments. So before we start the live demo, I'm just going to show you the XebiaLabs website. So obviously, you found the CollabNet website. We've obviously got a lot of information on there about the TeamForge platform. But let me also show you the XebiaLabs site. So this is the XebiaLabs website. As you come to their main homepage, you'll notice the overview of the different products. It helps you fit their product relationship into the TeamForge architecture as well. So this is the best place to come to for additional information about the XebiaLabs products specifically. And then what we'll do now is we'll step into a live demonstration of the way these tools can be brought together in a more sort of practical example. So this is the TeamForge project homepage. So TeamForge is a web-based platform. It provides all of the development services a project would need through this single point of entry. And this is one of the main values of the TeamForge platform, is that for any given product or program of change, we can centralize your point of entry to all of the different tools that your development teams and various stakeholders will be using. So we've got things like the change management tool, the tracker, source code, build and test. You can see that this really sort of lays out the steps of your development workflow. And we've also embedded our environments in here as well. So we can actually have this point of entry for the running application. And the idea is that we can build a view across this product, or this program of change, and bring in all of the various stakeholders into the TeamForge platform so that everyone has a single location to come to. This is also where we radiate information about this project. So I've got a basic example on this page that's showing my build status. It shows the history of my builds and how long they've taken. But we can embed any sort of information we want in here. So all our analytics, output, our operational reporting, everything can come back into this TeamForge project so that we have a single point of entry. And what we're looking at here is one specific project container within TeamForge. And this is specifically based for an application that is called Aurora. It's a demo application that we've used. And what we're going to do today is we're going to look at the Aurora application, and then we're going to go through and we're going to fix some defects on here. So within, let me just let the page load. So within TeamForge, the majority of the activity that happens is driven from the tracker. And within the tracker, we have this concept of planning folders. So as a developer, I know that we're currently working towards release 1 of our Aurora product. And we're actually in iteration 1. So here you can see we're looking at the backlog for iteration 1. We have a selection of user stories, which in this case have been broken down into tasks. We have an impediment here and test cases. We're also tracking defects. As our continuous testing has taken place, we're working within this iteration. We're also using a defect tracker to capture the relevant defects. It's one of these defects that we're going to fix today. So just a few words about the TeamForge tracker while we're here. What you can actually see on the sort of the lower right-hand side of this page is the hierarchy of work items that we've built up in this project. So we've identified the different record types that we're interested in. Within TeamForge, they're called trackers. We have a tracker for epics, we have a tracker for stories, we have a tracker for development tasks. We also have a defects tracker. And you can actually use these trackers for tracking anything that you want. And when you start building associations between these objects, it allows you to build a model of your dependencies within your work tree. You know, this is the hierarchy of activities that we have to complete to finish our product. As I said, we're going to focus on one of the defects today. We're going to pick this one. This is artifact 2816, and this is a defect that explains that the get a quote text on our homepage should be in bold. So one of the things I'm going to do now is I'm actually going to go to our running application, and we're going to have a look at that and see if we can identify the defect. Now, I know that the actual application is not deployed at the moment. So when I look at the running application, we can see our application doesn't exist on the server. I'm actually using it embedded within my TeamForge project, so I don't need to even explain to my developers where the application actually sits. So one of the first things I'm going to do is I'm actually going to deploy the latest version of the application to our dev environment so that I can see what the application looks like today. So we're now in our XL deploy tab. So this has brought us into the XebiaLabs deployment tool. From here, I can start, really simply trigger my deployments based on pre-configured application and environments, and I simply pair them up, and I can do the deployment. So I'm going to take my dev environment. I've placed my dev environment into the deployment view. I'm going to take version 9, the latest version, or build 9 of my application. And I'm going to deploy this application onto our Tomcat virtual host here. So this is all of the steps that I need to go through to deploy a version of my application onto a particular environment. And this can all be governed by role-based access controls. So I could say that for my development team, anyone who is identified as a developer within my project has the ability to go out and deploy these applications onto my dev environment, any version of the application, anytime. So what actually happens now is that XL Deploy will analyze that deployment, and then I'm going to execute it. We'll run through this again in a bit more detail in a minute, so I'm not going to go into too much now, but we'll let that execution take place. So this takes a few seconds to run. There's a Tomcat container behind here, so there's timeouts and starting and stopping the Tomcat service. So it's running through its automated script. So now that I've refreshed our view, I can see that our application's been deployed to our dev environment. If we go and look at our defect report again, we'll be able to see that this get a quote information here, this should be in bold font, as an example. Now, the way a developer would actually be interacting with this tool may not be through the web interface. This is a Java app, so as a developer, I'm more likely to find myself in something like Eclipse. So what I'm actually going to do now is I'm going to switch over to Eclipse. We'll find that same defect report in our Eclipse view, and we'll actually start making some changes to the source code. So this is Eclipse. And what I've done is I've configured the Mylin integration here to have a query against the tracker for this project. So as a developer on the Aurora project, one of the things I'm interested in is any defects that are opened in the current iteration. We use the defect tracker in our team to communicate any anomaly where a piece of functionality doesn't match the definition of a user story, for example. So we're just using this as a to-do list. It's a communication mechanism within our team, for example. So this is one of the folders I'm monitoring, and what Myelin and the CollabNet desktop integration for Eclipse will do for me is it will notify me actively within my IDE whenever new defects are raised by the team. We might have a convention within our team that this is identified as a priority task. So I'm actually going to activate this task. Because of the way the integration works, it's already opened up the source code for me from the last time I was looking at this task. And I can actually see here the source code for this project page. If we open up the defect in Eclipse, we can see that the get a quote text on the home page should be in bold. So we're going to go ahead and make that change now. Here's the text. So what we're going to do is we're just going to put that in some tags, which should make that text bold. So I will save that. Now this application actually comes from a Git repository that's hosted on the TeamForge platform. One of the things that we do as a team is we're using Gerrit as our code review step to ensure that we're achieving the right level of quality and as a level of collaboration within our project. So I use the team menu within Eclipse to add that change to my index. And then I'm going to do a commit here. Now with Git, commits are local, so this is a commit to my local repository. I'm going to include the Gerrit change ID in that, and I've actually got my commit message pre-formatted so it will create the right association with the artifact that we had open at the time. So there's really not much more for me to do here, so I'm going to commit this change. And this is now committed locally. So the next thing I need to do is push this change up to our TeamForge server so that it's submitted for review and the rest of my team can start interacting with this change as well. Okay, so because we're using the Gerrit code review, I'm actually going to push this branch to a special branch. I'm going to push this commit to a special branch called refs for master. So this will actually submit my change into Gerrit rather than the Git repository directly and prepare it for review and acceptance into the master branch in our repository. So this is the change I expect it to push. This is the repository I'm pushing it to. So we will allow that to run. Here's the summary of our changes. This is great. Click OK. And the other thing we'll do is we'll just make sure that our local workspace is totally up to date. So we're going to do a fetch from, or we'll do a pull, and that'll do a fetch and merge for us. Okay, that's fine. Now what I'm going to do is I'm actually going to switch over to Gerrit and we can review our change. So within our project, you see that we actually have a Gerrit tab here. Now this is the code review component for our project based on Git. So I'm going to open that in a new tab. And what we should actually see here is our incoming change from that commit. I go to all my changes. You see we have an incoming change for this. Get a quote text on homepage should be in bold. We can open this change. We can see which files were modified, who did it, and we can interact with this change request. So we can see here that the change that would be submitted as part of this commit is exactly what we would expect to see. And what we're going to do is we're going to just reply and mark this as accepted. Now this process, there are many, many ways of running this sort of code review process. So something like this verified step is something that you could automate. We would use our Jenkins build jobs maybe to monitor these incoming reviews. If they compile, we would verify them +1, but we'd still ask for human interaction to do the actual code review. We can set up any sort of policies and rules that we would want. In this case, I'm an administrator, I'm working on my own, I'm reviewing my own change for the sake of the demo. Yes, it works. Good. Best. And now we can actually submit this change into our repository. So Gerrit has now taken that change and has placed it into the Git repository for Aurora. Now what we're going to do is we're actually going to come over to our build and test tool, and we're going to trigger a new build based on the update, the new change. So this is our Jenkins view. What I'm actually going to do here is I'm going to trigger a new build. So we'll get a new build based on the latest content of that Git repository. When I trigger the build, I'm going to go into the change log and actually try and follow that as it dynamically loads on the page. So what we should see is the build job actually checking out the code. It'll perform the build activities based on the Maven build file. And then it will actually perform some post-build actions. And they're the steps that we're really interested in. So I'm going to do that now. Okay, so that ran pretty quickly. So what we can see from the log is actually the standard sort of Maven build script has run, and then there's some specific post-build steps that we've triggered, and we'll review these in turn. So the first thing it's actually done is it's taken the contents of our change and uploaded it to the CollabNet file release package area. So we can think of that as some sort of artifact repository within the TeamForge project, somewhere to store files. The other thing it's done is it's actually taken the WAR file output and pushed that up into the XebiaLabs XL Deploy product. So we've got copies of our build assets both within our TeamForge project and now in XebiaLabs. We've registered a new build of our application. So let's go and look at those two things. So within my TeamForge project, if I come to the file release section, you can see that I actually manage two different packages within this project. So we've got the Aurora web app, which we've just made a change to, and we have the Bazel app, which is an analytics package. We're not looking at that today. So within the Aurora web app, we have a single release that we're tracking. We're still in iteration 1 of release 1, so we haven't done any release builds. So I just have one release here called the master build, and this is built from our master branch within our Git repository. And you can see here we have the WAR files been uploaded. So we have a permanent record of the latest build available here. Now we could actually put the build number in the file name there and have a consistent record of all of the individual builds. But as we're in an early development phase, we're just really interested in the latest build so that we have a single point for people to go and pick this up. The other place that I said that this was going to be located was in the XL Deploy product. So let's go and check to make sure that's actually happened. So the build that we triggered was build 10. So when we start looking at our packages on the left-hand side again, we should see build 10 for our Aurora product. Here we go. So we have build 10. Now what we need to do is we actually need to deploy again to our dev environment so that we can actually review that change in the live environment. Let me close some tabs here. So what I'm going to do is I'm going to open up the dev environment again. We can see that this is still the version without the strong text here. So I'm going to undeploy this version and I'm going to deploy build 10 to our dev environment, and we'll refresh this page to make sure it's made the expected change. So dev currently has build 9. We will undeploy this. These are the steps required to actually undeploy an application. So you can see that it will stop the Tomcat service. It will wait for 10 seconds for the service to actually stop. It will destroy the assets on the server, and then it will restart that Tomcat service. So it knows how to deploy and undeploy applications to standard environments. So let me execute that. Okay, so that's now finished. So we should see that our application's been undeployed. So let me refresh our dev environment. Yep, our application no longer exists on our dev server. So now what we'll do is we'll do a deployment for version 10 of our application. So I take version 10, and then I select our dev environment. And this is all that's required from a user to actually deploy versions of our application to this environment. It makes this process so simple. It's really controlled. I don't need any access to the actual infrastructure for our test and production environments. I don't need to understand even how the deployment has been designed. I can have a simple drag and drop interface to pick and choose which assets I want to deploy and which environments I want to deploy them to. Now, this is obviously a very simple example, but the CebiaLabs XL Deploy product understands a lot of different types of web containers and different environments, and it can reach out and orchestrate all sorts of external services. So a small amount of work spent here sort of codifying the way you're going to do your deployments means that your development teams and your other stakeholders can be very, very productive to schedule these deployments, actually trigger them, and do it in a controlled way. And obviously there is an audit trail behind this as well. We can tell who has come into this product, who has deployed which products to which environment, and we can put the right roles and permissions around that to limit it. And what this ultimately means is that the actual deployment of our application to our dev environment, to our staging environments, and to our production environment, it is codified, it is automated, and when we actually come to deploy to production, the risk is as small as it can be. That deployment process or that deployment recipe has been run 1,000 times in development, and to actually get it to production is simply a case of role-based access and nothing more. So let's actually look at some of the steps that it will do here. So the first thing it's going to do is actually move our web application container up onto the environment. It's then going to take the relevant steps needed to actually deploy or install that asset, and then it cleans up its own assets from the server. So the before and after state should simply be the newly deployed application. So I'm actually going to execute that set of steps now. Okay, that's our deployment complete. Let's go and look at our dev environment and make sure that the change is what we expect to see. So I'm going to refresh this one more time. And we see now that our text here is in bold. So this is what we expect to see as the change. And you can see here that I haven't had to have any special knowledge about the server that this application runs on. I don't have to have any special knowledge about how it actually deploys. And I don't have to have any privileges on any of the infrastructure that sits behind this. I'm doing this purely through a web interface. Almost everything here has been done point and click with the mouse. This is a very, very controlled way of doing this. And as I said, it allows your deployment to dev and UAT and your deployment to production to be essentially identical processes, something that is codified and automated. and the target environment is governed simply by role-based access. So the last thing we need to do, we've obviously picked up this defect, we've made the change, is we need to go back and actually resolve this defect. So what I'm going to do is I'm going to move this to closed, resolved by adding strong tags. Update and view this. So I've updated the artifact. The other thing that I can do as well from this screen is I can go and look at the associations. So we can see that our commit here has been associated as well. So we still have this full chain of audit trail and evidence for changes that have been made against this defect. We can have that traceability now from the original change request through to the code modifications through to the build, because obviously the build knows which commits have come into it. The build also knows which deployment assets it's created, and XL Deploy gives us that audit trail of where those deployment assets have actually been deployed to. So we have a system here with a single point of entry for all our users that maintains a full audit trail of everything that happens within our development chain for this product. So that's everything I wanted to show you today. I hope this has been informative, and it shows you how some of the more abstract or complex DevOps topics can be turned into something more concrete, something that is going to be obviously valuable to your development teams. The productivity gain here from allowing the teams to do these deployments and manage these environments through such a simple interface is hugely beneficial. The effort spent setting up that interface is not high, and it saves repeated effort within your team over and over again. So as I said at the beginning, if there are any questions, please put them into the chat. I'm actually going to hand back to our webinar team now. So it's been very good to talk to you today, and I look forward to answering some of your questions as they come in if they haven't been answered already. So thank you very much.